In this video, I will discuss a JEE Advanced PYQ from the topic Work, Energy and Power. This question is a simple question based on the definition of work done. Let me consider a body moving along this path under action of some force. So let the force at this point be in this direction, and let the force be non-uniform force. So the force could change in direction and also magnitude from point to point. So the work done to move from this point to a small distance point, say the distance is ds. The work done is given as f dot ds, and this is a small amount of work. It's denoted by dw. If you want to find the work done to move from some initial point here to some final point here, then the total work done to move from the initial point to the final point will be integral of f dot ds from the initial point to the final point. F is a vector and d is also a vector, so this is nothing but integral of f into ds into cos of the angle between these two vectors, cos theta. So here theta is this angle. With this understanding, we can solve this JEE Advanced question. This is the question. A light inextensible string that goes over a smooth fixed pulley, as shown in the figure, connects two blocks of masses 0.36 kg and 0.72 kg. Take G equal to 10 meter per second square. Find the work done in joules by the string on the block of mass 0.36 kg during the first second after the system is released from rest. You can pause and note this question. The work done by the string on the block is basically the tension force, work done by the tension force. Two blocks of mass 0.36 and 0.72. So the lower mass is this one, which is 0.36. So you have to find the work done by the string on this m mass during the first second. First second means from time t equal to 0 to t equal to 1 second. So first we have to get the value of the force, which is the tension force. So for that we have to draw the free body diagram of this small mass m. There will be a weight acting on this mass, which is mg. And this 2m is heavier, so the whole thing will be 2m will be going down and small m will be going up. So the acceleration of this small m will be upwards, say, and this string is inextensible and light, so the acceleration of this 2m will be same a but downwards. Force acting on 2m is the weight due to Earth's gravity, which is 2mg downwards, and the same tension force. String will always pull the mass. So if you write the equation for the first mass, the net upward force is T minus mg, which is equal to mass into acceleration according to Newton's second law. For this 2m block, the net downward force, because it's going down, net downward force is 2 mg minus t, is a corresponding mass 2m into the same acceleration u. So you have two equations and two unknowns. One is the tension, other is the acceleration. We have to find the tension because we have to find the work done by the tension. So to get tension, we have to eliminate a. So we can divide these two. So that will give it T minus mg by 2mg minus t. A will get cancelled, so that's equal to half. So this, if you simplify, 2t minus t, so it will become 3t, and then 2mg, 2t minus will become 3t. Okay, so and then here is minus 2mg, and here is 2mg, so it will become 4mg. So tension is 4/3 mg. Using this thing in the first one, I can get the acceleration. So now using this in one will give me t minus mg. T is 4/3 and this is 1, so it will become 1/3 mg equal to m into a. So this will give me acceleration as g by 3. So to find the work done in the first second, work done for a short interval of time, dw is F acting on this mass m, which is the tension, dot its displacement. Okay, and both are in the same direction, tension and the ds. Tension is upwards and the thing will move up, so ds is also the same direction. So angle between t and ds is 0, so this will become t into ds into cos 0 degrees. And tension we have found out as this one. So this work done you have to find for the first second. So that is from t equal to 0 to 1 second. So you have to integrate this thing, integral t ds, cos 0 is 1 from time t equal to 0 to 1 second. Tension is a constant tension. It is not a function of time or space. So the tension value will come out of the integral sign because it's not a variable. It's 4 by 3 mg. And integral ds for the time 0 to 1 second. So this is the total displacement during the time t equal to 0 to 1 second. This we have to find out. This mass is moving at a constant uniform acceleration because the force acting on it is constantly uniform, and that acceleration is being found as g by 3. So to get the displacement in the first 3 seconds, we can use the equation of motion, which is valid for uniform acceleration, is equal to ut plus half e t square. Here acceleration is uniform because the force acting on the mass m, which is the tension, it's uniform and constant. It's not a function of space or time. So this equation is valid, and starting from rest, so u is 0. So first term is 0. So only the second term will come. Acceleration is, we have found it as g by 3. And t is 1 second from 0 to 1. So displacement is g by 6. If g is in SI units, it will be in meters. So using this thing here, work done in the first second, that is from 0 to 1 second, is 4 by 3 mg into the displacement is g by 6. And mass is given 0.36 kg because two masses, one mass is 0.36, other is 0.72, so m is 0.36. So 2 and this thing will get cancelled, so I can write 2 by 9. This is 2 into 3, so 1 2 will get cancelled, 2, and 3 will become 3 square. M is 0.36, and then G square is 100 because G is 10. So 36.6 into this one is 36, so we'll get 4. So this will give the answer as 8 joules. It is the correct answer. This one I explained here. So there are two masses M and 2M. Starting from west, this is a heavier mass, so this thing will go down and this thing will go up. Tension is same throughout because the string is inextensible and light, and the force acting on this M is the weight mg and the tension force upwards. On this one it's 2 mg downwards and tension upwards. Acceleration is same. So the net upward force on this small m is T minus mg, which is equal to the mass and acceleration, which is upwards. 2m is going down, so the net downward force is 2mg minus T, which is equal to mass and acceleration of the second one. So you have two equations and two unknowns. One is tension, one is acceleration. To get the tension, you have to divide these two so that acceleration will disappear. So 1 by 2 will give me T minus mg by this one, put half. So tension is 4 by 3 mg. And to get acceleration, we can use the first one or the second one. Using the first one, I'll get tension is 4/3. So 4/3 minus 1 is 1/3. So 1/3 mg equal to meta. So acceleration g by 3. So work done in the first second is F dot ds between the time interval 0 to 1 second. And the angle between F and ds is 0 because the force acting on the mass n, which is the tension, it's upwards along the string, and d is also along the string, same direction. So the angle between the force and the displacement is 0. And force is the uniform force. It's not a variable, so it will come out with the integral sign. And if we get integral ds, it will be total displacement in the first second. To get the total displacement in the first second, I can use this equation of motion because this is valid for uniform and constant acceleration, which is true in this case. And it's starting from this, so the first term is going with 0. And half acceleration g by 3 we found out. And t is first second, so 1 square. So displacement is g by 6. So work done is tension, which is 4 by 3 mg, which is the force, into the displacement, which is g by 6. So mass is the 0.36 kg, and g square is 10 square. So simplifying, right, 8 joules.